hello everyone, welcome to the week 5 tutorial solution of the assignment which we have discussed in week 6. Sorry, in this particular week, in the last class we had discussed about the empirical, how do we use that written level analysis using and you can calculate the corresponding probabilities of extreme events using some sort of empirical approach. So, why it is important? Because let us say you have a time series data set that can be, we can use it for let us say you have collected some sort of maximum rainfall or maximum discharge or maximum temperature, and now you are interested in what is the probability of occurrence of different events, and then you are also interested in, let us find out the probability of occurrence of 10 years or 20 years or 50 years or 100 years extreme events like that. So, how we can use it, this empirical approach. So, let us suppose we have let us say collected the maximum, let us say we have observed the daily rainfall data set for one particular locations. Let us say for 365 days in a 1 year we have recorded daily rainfall. So, this daily rainfall should have a maximum value where the peak value, and we have a minimum value, probably that is 0. So, that is maximum value we can take, and then we can, for each year we have multiple maximum values like that. So, let us say we have collected the data for 10 years and we are reporting this data like this. So, let us say this is year information, and that is first year, let us say this is second year, let us say this is third year, this is fourth year, this is fifth, this is sixth, seventh, 8, 9, 10. Okay. Now, you have R max. Let us say in first year you have 90, in the second year you have 110, in third year you have 95, in fourth year we have 130, then fifth year 105, then you have 125, then we have 85, then we have, let us say 115, then we have 100, and then we have 120. So, these are the R max value which we have reported for different years. Let us say year means this, let us say these are the number of years which we have. So, when we are trying to find out the probability and corresponding written levels using the empirical approaches, so we have to find out, the step 1 is we have to make rank the data set, rank the data in descending order. How do we do that? So, let us say you have year information, you have R max information. Now, you wanted to rank the data into different based on the magnitude. So, let us say you can write here rank of the data, okay, and this is your rainfall maximum amount, let us say. So, let us say we are writing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The maximum value of this data set is 130. So, this is 130. The second maximum value is 125. So, that is 125. The third maximum value is 120, then 115, then we have 110, then we have 105, then we have 100, we have 95, we have 90, we have 85. So, these are the ranking of the data set. Now, we have already ranked the data based on their descending order, the highest one is the first rank and the lowest one is the last rank, like that. Then we will basically apply again the step 2 is to apply a probability formula to calculate the probability of occurrence of these different events. The formula is basically probability is equal to the rank of the data divided by total number of values plus 1. Okay. This is called Weibull formula for empirical probability calculations. Okay. Now, how we can calculate the probability? So, what is the rank here? Rank is for this particular value is 1, okay, divided by n plus 1. How many numbers are there? 10 plus 1. So, what is the value of this? You can calculate. So, 1 divided by 11, that is coming out to be 0.09. Okay. So, this is the value of this probability of first or the highest event. Similarly, you can calculate the probability of the second rank, which is 2 by 10 plus 1, which is basically we can again calculate 2 by 11, that is coming out to be 0.182. Okay. Then we can calculate the third event, third by 10 plus 1, which is coming out to be third by 11. 1 minute. That is coming out to be 0.273. So, similarly, you can calculate the probability of all these different values based on this particular formula, and based on that you can basically get an idea about what is the probability of occurrence of each different events. Let us say if you calling 130 R max value, the probability of occurrence for this particular data set is basically 0.09. Now, you recall we had discussed in the previous lecture that when we have the probability value, so if we inverse the probability value, we will get the written years or written periods. So, for the first value we have the probability is let us say 0.09. Okay. So, the first rank event, so let us say this is rank 1. So, we have written period is equal to 1 by p, which is basically 1 by 0.09, which is we can calculate 1 divided by 0.09, which is coming out to be 11.11 years. So, which means for R max is equal to 130 mm, let us say magnitude, for this particular data has 11 years or 11.11 years, roughly 11 years of the written period. Every 11 years we have the high probability of one R max event which are close to this particular magnitude or like that. So, this is how basically we have calculated the probability 0.09, and based on the probability we have converted into the written period, and based on that we have associated that written period with your corresponding magnitude, and then we basically correlate. Similarly, we can calculate the second rank event. which is the rank second, we have R max value is equal to 125 and the probability value was equal to 0.182. So, for this return period we can calculate 1 by p, which is 1 by 0.182, which is 0.182, that is coming out to be 5.495, or maybe we can write 5.5 years. So, which means when we are talking about 125, we have probability is this, we can calculate the return period, that is coming out to be 5.5 years in the data set. So, this is basically we have we can calculate the probability of each different events, we can calculate the return period of each different events based on whatever data set we have, and then we can try to look at a sort of a relationship between these different events. For example, let us say So, for example, let us say we have we know that what is the magnitude of R max, because we have the data set. So, we know that R max magnitude, and correspondingly we have also calculated the return period. So, for example, this is 1 year, then let us say we are plotting in a log 10 scale, this is 10 years, then this is 100 years, like that. So, or maybe beyond that. So, we have some value here, then some value here, then some value here. So, basically based on this we can make a one kind of relationship between R max and return period. So, let us say we have calculated this value, this value, this value, this value, this value, this value, and then basically we can so let us say this is x1, this is x2, this is x3, this is x4, this is x5, this is x6, like that. Then based on that we can also calculate, if we have fitted a line with the data set, we can also use in between values. For example, we know that what is the return period for 1 year, then we know that what is the return period for 5 year. We can calculate what is the return period for, let us say 2.5 years, because we have already fitted the line, and using this particular line we can basically interpolate in between 2 points, and we can interpolate between 2 points, and then we can calculate what is the magnitude of the rainfall events when the return period is equal to 2.5 years, like that. So, how do we do that mathematically? So, basically let us say we wanted to find out the return period magnitude when t is equal to 2.5. It can be the first value is x1, what is x1? This one, or a corresponding value of x1, okay, plus the slope of the line, which is let us say x1 minus x2 divided by t1 minus t2 between these 2 points, x1 and x2, t1 and t2, okay. And then you can basically calculate what is the t1 minus, let us say t. So, here what is t is? T is your 2.5, t1 is your the first value, okay. T1 is your basically equal to 1, t2 is equal to 5, t is equal to 2.5, x1 is equal to let us say some value, okay. X1 is your first R max value, and x2 is equal to the second R max 2 value at 5 year return period. So, you know all these values, you can put in this equation and you will be able to find out what is the t is equal to 2.5 xt, that is basically the magnitude of event when it is equal to or 2.5 like that. Sometimes it is also possible that people also do, because when we have less number of data set, let us say we have done this analysis again, this is your let us say x variable, x can be your rainfall maximum, q maximum or t maximum or any extreme events like that. Then you have return period here. So, suppose you have done this is 1, this is let us say 10, then we have not more than let us say this is 20 like that. So, we do not have data set beyond 20 years or like that, or we have not calculated it. And then we have fitted a line that is like this, here we know, in between we also know, here we also know, here we also know, like that. So, let us say if somebody says that okay, please do that analysis and give me the information about 100 years. So, we assume that the line would be will follow the same slope and same intercept which we have fitted for the known points, and we are trying to get a extrapolation of values. When we do extrapolation, it might possible that we have some sort of higher uncertainty, because in this range this is known range, this is known range, this is the data set we have already, but here we do not know the data set, it is beyond the range of the data set. So, when we calculating the data in between, which means if you compare to the uncertainty, it might have lesser uncertainty, because the data we have only for this particular point, but when we are extending this analysis for more data points beyond that range, it might have a higher uncertainty. For example, if you are calculating for 100 years, it might have higher uncertainty, but you can do that. So, same procedure. So, let us say this is your first point and this is your last point of the data. Okay. Now, you are you can calculate the slope of the line. Let us say so you can put basically let us say x t is equal to 100 is equal to, let us say you can write the x1 plus, you can calculate the slope of the line x1, or let us say you can write here I am writing xf probably, and then xl the last one, and then you can also write the first tf and tl also, and then basically you can multiply with tf minus t100 like that. So, with this formula we would be, we know that xf, we know that xl, we know that tf, tl, xf and tf. So, if you put all these value and we know that this is 100. So, that we can calculate what is the return period of an event which has a return period equal to 100 years. In 100 years, this is the higher chances that one event will come, surely will come, or higher chances that this will come. So, basically this is how we can calculate the return period analysis using this kind of the methods. So, basically this is a very simple way to dealing with this. How do we implement all of these? You can use for rank calculation and rank based probability calculation, you can use some sort of Excel software, or maybe you can use MATLAB to do this kind of analysis. So, you just make sure that whenever you are using this analysis, you should have independent data set, which means the data should follow the independence rule, which means it should not be physical process dependent upon the neighboring events. So, suppose you have taken maximum value of any particular extreme event, so which has a higher chances that in 1 year the maximum value, in the second year the maximum value, which may not have a very direct relationship, which may not have a very physical relationship when we are considering, let us say there is a event, a maximum event, and then there is another event, subsequent event. So, it has a higher probability that these two events are correlated with each other, and therefore, you cannot consider these two events are as a independent event. This is basically a dependent event with each other. So, probably we have higher magnitude of flood. Because of that, the soil moisture has been increased, and again the lower magnitude of rainfall, but you have higher flood conditions, which is like this. So, that is basically governed from the first peak, because it has reached the soil moisture level, and therefore, you have higher peak value because of the neighboring events like that. But when we are considering that 365 year window, we are taking the maximum value from each different years, and therefore, it might possible that these two events are not directly dependent, and we can consider them as independent events, and then thus we have the independent event. We can make the data set, which is xt. We can calculate the rank of the data, we can calculate the probability of the data, and then we can calculate the return period of the data set. So, once it is done, then basically we can make a plot of the data set, and then we can relate your extreme value and return period, and we can calculate the return period for return period and magnitudes. So, this is how basically we can do this analysis, and we can perform this empirical based analysis for this extreme value type data. So, you can try using these analysis in Excel or MATLAB or any particular software where you can implement all this analysis and calculate and make some sort of plots, and then calculate, interpolate or extrapolate of your different types of return period values, and calculate the corresponding return period magnitudes. Okay. Thank you so much for listening, and I hope that you have understood the concept behind how you can apply this empirical based probability calculation method to calculate the return period and corresponding probabilities. Thank you so much.